Hello and welcome. In this video, you will learn how to get started with Earth-2 for AI weather forecasting. If you follow along, you will be able to run your own global weather forecast in just a couple of lines of code. Earth-2 is a platform for accelerated weather and climate modeling. Within the Earth-2 AI toolbox are two open source Python libraries, PhysicsNemo and Earth-2 Studio. PhysicsNemo is a library for training AI physics models, which includes weather models and models for other applications like fluid dynamics. Earth-2 Studio provides components specifically for AI weather inference pipelines. To initialize your weather forecast, Earth-2 Studio provides data sources like ERA5, IFS, GFS, HER, GOES, and many more. Switching between data sources is possible by changing a single line of code, making experimentation, testing, and benchmarking easier than ever. Earth-2 Studio also provides access to numerous pre-trained models out of the box. For example, ForecastNet3, AIFS and Aurora for global forecasting, and Cordif and Stormcast for regional weather modeling. All models define a unified interface, which makes it easy to switch between models, combine multiple models, and bring your own model. Output data can be written to SAR and NetCDF, and processed further with standard tools like Xarray. Earth-2 Studio also provides a library of examples, recipes, and more involved workflows to get you up to speed quickly. You can follow along our short tutorial if you have access to an NVIDIA GPU with at least 80 GB of memory, like an A100 or newer. Earth-2 Studio requires Python version 3.11 or higher. The user guide provides detailed instructions on how to access different models. We start by importing the necessary components: data sources, I/O backends, models, and the default workflow. Then we load ForecastNet3, which is an AI weather model for global forecasting. Each model interface defines a class method called loadModel that accepts a model package. This package defines the individual components of each model, for example, weights and normalization constants. Pre-trained models have a default package that pulls the required data from a repository on Hugging Face. After loading the model, we define the data source and I/O backend. For this first example, we will use IFS analysis data from ECMWF and write our outputs to NetCDF. Now we can already run our workflow. The deterministic workflow produces a single trajectory of future weather variables. Earth-2 Studio also provides predefined workflows for ensemble forecasts and for coupling two models. You can use these workflows as a template to develop your own custom workflow. The workflow function expects a start time. We will use January 15th at midnight here, and the number of forecast steps. Then we simply pass the model, data source, and I/O backend we have created previously. Inference on our NVIDIA GPU is super fast and will finish after only a couple of seconds. Let's have a look at the output by opening it with Xarray. The animation shows the forecast for 2-meter temperature over the course of the 4 following days. Now let's explore other models. Accessibility is one of the key objectives of Earth-2 Studio, and switching to a different model like the ensemble version of ECMWF's AIFS requires changing only a single line of code. We can leave everything else the same. After waiting for the inference to finish, we can compare the results to the outputs we got from ForecastNet3. The same works for Microsoft Aurora. Just change the model class and rerun the workflow. Do you want to initialize your forecast with GFS instead of IFS? You know what to do. Change the data source to GFS and rerun the workflow. Maybe you would like to run a historical analysis based on ERA5 instead. The same concept holds for I/O backends. Write the output to SAR or work in memory by passing the respective backends to the workflow. We hope you enjoyed our short demo of Earth-2 Studio. If you want to learn more, visit the GitHub repository and check the user guide and examples. Thanks for watching.